Okay. Okay. So thanks for joining, guys. Hope you're doing great. Yesterday I had a rose workshop. So I couldn't able to like take the session. So today we will be continuing with the topics that we have discussed in the last class. Okay, I'm not sure you remember the things that we have discussed in the last class. Basically, I have demonstrated the Hello World uh, program using ROS. Okay, so we didn't discuss the program. I just shown you like how the hello world of ROS looks like. Okay, so before that we talked about the inter process communication, like how the ROS nodes are getting connected, all those stuff. Okay, so maybe I can start with the hello world so you will get an understanding, and then we will go to turtle sim. Then so the turtle sim is actually a tool for learning ROS, okay, for practicing, because ROS in the ROS equation we can see four things like the plumbing, then tools, then capabilities and ecosystem, right? So you will get that equation from the ROS website itself. And I also mentioned a slide in our GitHub repository that is also having that. Okay, so maybe I can just show you that, just a second. Yeah, so this is equation. So regarding the tools, ROS actually giving two type of tools. One is graphical tools, and one second is the command line tools. So what is the use of these tools? Mainly for debugging and visualization, meaning from the plumbing or from the inter-process communication, ROS is actually creating a graph. It's called the computational graph. Okay, so I think I have shown you the slide. Maybe I can just show you again, because this is a fundamental concept. So if you are not clear about it, then you can't able to program. Okay, so I just included the PDF. Let me check whether it is loading or not. Yeah, the slide is here. So what I mentioned was yeah, the computational graph. I mean, I have shown an example. So this is a connection. This is a list of ROS nodes or process running on the operating system or in the robot, and all these processes are communicating with each other like this. Okay, randomly communicating. Communication means exchanging some data, and when it communicate, it is actually forming a structure like this, a graph basically. Okay, so we are calling this structure as computation graph because each process is doing some computation. Okay, and in the ROS terminology we are calling ROS computation graph. Okay, this is ROS computation graph. So why? Because we are using ROS API or ROS function to able to communicate with different programs. Okay, so this is the basics of you need to know this, then only you can start programming. Okay, and also the concepts. I'm not sure you you are remembering all the concept that we have discussed, which is ROS nodes, which is the running instance of a ROS program, then ROS master, which is actually a program that we are getting when we install ROS, which is actually like a broker program. Okay, and then the parameter server, which is actually for storing the parameters. For example, if these 7 programs need to access a common variable, okay, a common value or something, then you can store that value in the parameter server. Parameter server is a program actually. So when you execute the ROS code, the parameter server will also start, and then you can store the parameters into the parameter server, and then all these nodes can access those parameters. Okay, and you can also use privacy, so that some parameters will be only visible for some nodes. Okay, Okay, and we have discussed about the topics. Then we discuss about services, I guess, and actions. Yeah. Okay. So just go through it. Okay. Services. I mean, topics are like asynchronous communication. Like one node is sending data. Without any acknowledgement, is continuously sending the data. And other is receiving it. So one node can publish and anyone can subscribe it. Okay, so the publisher and subscriber are like anonymous basically. Like publisher doesn't know who is subscribing to it, and subscriber doesn't know who is publishing it. Okay, it's basically is connected, and like it's publisher is publishing and subscriber is just consuming. Okay, in ROS service it's basically like synchronous communication, like a request response. One node send a request to another node, and the second node will acknowledge it and then process its request and send it back. That is ROS service. And the ROS action is basically like an upgraded version of ROS service, which is somewhat complex as well. Like in this case, client is sending a goal, and then if the task is taking time, then if you give any task to the ROS action server, these server and clients are nodes. The server is also sending the feedback of the process. Feedback of the task. Like if the task is like counting 0 to 10,000, like the server will be giving some feedback to the client. I just counted from 0 to this, something like that. And after doing that, after completing the task, server will send the results. Okay, and one advantage of the ROS action is if client wants to cancel the request, okay, then client can do that. Okay, it can preempt the request. Means I have sent a goal to server, and server is processing it, and if it is taking too much time, we can simply cancel it and then we can give another goal, like that. Okay, so just understand these concepts. Okay, then only we can work with the next topic. Okay, so I hope you are clear with, at least understand these concepts. Okay, I'm just giving you like maximum 5 minutes to ask questions related to these ROS concepts. Okay, then I will be showing the ROS hello world, and then I will be explaining how the ROS topics works first. Okay, first I will show you how the topics work, and the visualization of the computation graph. Okay, then we will be jumping into ROS turtle sim, so that we can learn about almost all the concept in ROS, like services, topics, parameters, not actions, but all other stuff. Okay, so one thing about this course is that you can't simply hearing the lectures will not work, I will say. What I'm giving you is some pieces of knowledge, but you have to practice it, then only you can implement these things. Okay, so the practice makes perfect. There is no doubt about it. So after this we can see the practicing section. So after getting the video, you can start practicing whenever you get time. Okay, so I'm just giving 5 minutes maximum to do a Q&A. So so let me know if you have any questions related to this ROS concept, fundamental concept. Let me know. Any question, guys? Any doubts? You just need the fundamentals, how topics works, how two nodes are connecting each other. I think I have explained this. The master is doing that, and yeah, so if you have any question, let me know. So this is the advantage of live class. Like if you have any doubts, you can talk to the mentor. Otherwise you have to message to him. So do you have any questions? Okay, I think it's almost clear to you. So now let me jump into the hello world. Okay, so if you install ROS on your machine, then you will get some tutorials to practice ROS concepts. Okay, so that is what I am going to demonstrate. So um, no need to worry about um, commands. Okay, just see how the inter-process communication between two nodes working. Okay, so in this demo we are going to see how the talker and listener node that we have mentioned in the slide start working. Okay, so what is the first program, or what is the first command that we have to execute before starting the node? I think you know it, right? The ROS code. Okay, so that is the first command you have to execute before starting running any ROS nodes. Okay, this is mandatory. Otherwise, what happen? Otherwise, nodes can't find each other. Okay, so I'm doing the same ROS code. Okay, ROS code. So in the last session I just mentioned about this application. I think if you are starting working with ROS, this terminal application is very useful. You can simply install this application called Terminator. I'm just giving the command. So if you install the Terminator using the command that I have sent, then you can find it. Okay, so what is the advantage of this? You can create multiple terminals, okay, in the same window. Okay, so that is what we really require. So you can just split horizontally, then vertically. Okay, interesting, right? Okay, so we just started the ROSCO in one window. Okay, now what? Now we have to run the talker. Okay, so let's start running talker. No need to worry about the commands that we will be discussing after the demo. Okay, so I'm just running the talker executable, okay, which is already installed along with ROS. Okay, so let me start talker, and it's printing something, right? It's printing something, but we don't know what is happening in the background. Now I am running another node, that is listener. So ROS CPP tutorial. So basically it's a ROS and CPP tutorial. It is actually the executable. We can't see the code. So I'm just running it. So what you are basically getting from these two outputs? Like you can almost see the same data here. Here it is 4 3 and 4 4 something, and you are getting the same thing here. Okay, and if I just cancel or close this node, what happened? This is also closing. And if I restart this node, what happened? We are getting this data. So from a common sense, we can find there is something going on with these two nodes, right? Whenever this node stops, this node also pauses, but it's not closed. And currently the data is like 149, and when we start the node again, then the value got reset, and it is receiving the new one. Okay, so in order to fix our doubts, what we can do is we can visualize the computational graph. Okay, so from the computational graph we get to know which all are the nodes communicating with each other. Okay, and what is the ROS topic. Okay, you will get the ROS topic name. Okay, so all this information. So we can use a ROS tool called RQT in order to visualize the computational graph. Okay, so this is the computational graph. Okay, so from this, can anyone explain what is going on in the computational graph? Can anyone explain? Even if it is wrong, that is fine, I will correct you. Can anyone say what is going on now? Any idea, guys?
Yes,
Sir,
sir.
Yeah, yeah. Maybe Karthik, you can say first, and then I will go to
sir,
Tanuj. Yeah.
okay.
Yeah.
Sir,
Sir,
talker is
actually, there is a topic named chatter,
Okay.
right? So the listener is subscribing the data from the chatter topic, and talker is publishing the data on chatter topic.
Okay. Okay. Great. Great.
Yeah.
Okay, Tanuj. Yeah. Now I'm jumping to Karthik. So Karthik, do you have anything to say?
sir. Yeah, it's the same thing, sir.
Okay.
Chatter is a topic and listen is subscribing from talker.
Okay, okay, got it. Thanks, Karthik and Tanuj. So, what you have said was correct. Here, the talker and listener are two nodes. Okay, two nodes. And what is in between? The chatter, right? So, basically, chatter is a topic, okay, which is created by a node called talker. Okay, so talker is what sending the data, right? So that's why uh, chatter topic is created by talker. Okay, and then what happening is that talker created the topic and then started sending some data that we don't know. Okay, we just know that it is sending like hello world or something, but we don't know what kind of ROS message it is passing. Okay, that we can find out. And then talker is like publishing into chatter, and then what happened when listener comes, it is subscribing to the chatter topic. Okay, so then what happened? So if there is an interest for listener to subscribe to chatter, what happened? The master will connect them each other. Okay, connect them both. So then communication between talker and listener will happen. Okay, so this is what happening now. Okay, and then we can find it out what kind of message these topic are passing. So no need to worry about the command, we are going to practice it after this. So I'm just checking the chatter info using a command line tool. So I'm getting like it is using string. Okay, it is using string. Okay, so basically chatter sending a string message, ROS message, and a talker sending a string ROS message through a topic called chatter, and listener is expecting a string message from the topic called chatter. Okay, so if there is a mismatch between the publishing and the expected one, there will be an error. Okay, so both should be same, like the topic that is publishing should be same as the topic that is subscribing. Okay, and also topic the message that is publishing, which is string here, message that is publishing by talker will be same as the message that is subscribing. I mean the expected message should be matching, otherwise there will be error. Okay, so that's what I'm saying, like if there is a matchmaking, if there is a nice match, that's what we are mentioning in a matrimonial site or something, right? Like if there is a match, then it will start communicating. Okay, so this is the example that anyone can try. Okay, so the example is very easy to work out. ROS run space ROS CPP tutorial stalker, and then we can start ROS CPP tutorial listener in another terminal. Okay, so this is the example we have to write. Okay, so any doubts regarding talker and listener, guys? If you have any doubts, let me know. I think it's very basic example. We can say it's a hello world of ROS. Okay, but the next thing is the important thing. Okay, that we are going to discuss is the tools. Okay, especially the command line tools, and we will also see graphical tools. Okay, so from this simple example, how will we work with the tools? Okay, the most important part of the ROS course, I will say, the fundamental, obviously working, the practicing of tools, ROS tools. Okay, then only you can find it out, find the computation graph, what is going on in the background. Okay, so when you run something, we are completely blank, we are completely blind, and using the tools only we can identify what is going on. Okay, I think you have seen the RQT graph is visualizing the computation graph, so that is giving a big insight, because if there is a 20 programs running, and if 20 programs are communicating with each other, we will get a complex computation graph. Okay, and if we visualize it, then only we can identify the issues. Like if there is any issues, then only we can find it. Okay, so now what we are doing is we are starting practicing the command line tools and graphical tools in ROS. Okay, there are many tools, but I am talking about the important one. Okay, after that we will be going to the another next example, that is the ROS turtle sim. Okay, so you will get an idea from this hello world. Okay, then we will jump into the turtle sim. Okay, so let's start. So what I'm trying to do is I'm starting ROS core, then starting talker, starting listener. Okay, you can cancel these nodes, or you can just close this node by pressing Ctrl C. Okay, and you can close this terminal by pressing Ctrl D. Okay, so these two nodes are running. Okay, so I just want to know what are the nodes running. Okay, what are the nodes running? So you can easily find it out using the computation graph, right? Using the computation graph you can find it out. So but we have seen a GUI for visualizing the computation graph, right? But we can find it out, what are the nodes running, we can find it out using command line. Okay, so there are tons of command line tools available. So in order to find out the command line tools in ROS, what you have to do is just type ROS. Okay, then press the tab twice. Okay, so then you will get a list of command line tools. Okay, so from the name itself you can find the use of it. For example, the ROS node is a command line tool. Command line tool means it's just a command. Okay, I think you know the shell command, right? For example, the ls, it's a command. Similar to that, ROS is actually giving some command or command line tools. So what is the purpose of ROS node? Like you can just think ROS node will be for like getting the information about the nodes, or like just get an overall idea about the ROS nodes in the computation graph, right? What will be the ROS topic, to get an idea about the topics that is currently active. Okay, and also you can see what is the data going through the topic. You can identify what is a type of data going through the topic. Okay, then ROS SRV or ROS service is there, ROS service, which is actually for managing the services in the computational graph. Okay, you can list out the service, you can call a service, you can you can check the service, list the service. Yeah, and there is a ROS run. Okay, ROS run basically for running a executable, ROS executable. Okay, so when you run a ROS executable, then it will create a node. Okay, executable is just a file. Okay, when you compile a C++ ROS file, you will get an executable. Okay, so it will be only creating a node when it runs, right? Like nodes are the running entity of a program, right? So using ROS run, you can able to run a ROS node or ROS executable. Then important one is ROS graph is there. So ROS graph is giving the computation graph in terminal. Okay, but it's little complicated, but yeah, it's actually giving the computational graph in terminal. And we have ROS CD Okay, so that I will explain after some time. Then ROS core is here, ROS CP, ROS. I think this much of command will be enough for now. Okay, for the start. Maybe we can see with these list of command: ROS node, ROS message. Okay, what will be a ROS message from the word itself? You can check you can check up about the ROS messages, various ROS messages available. So ROS node, ROS message, ROS SRV. So this will be giving different service definition. So I will be mentioning it maybe in the programming section. Then ROS service. Maybe we can start. Okay, we can start. Maybe I can just create a list of command line tools, and I can do a demo of it. Okay, first we can start with ROS run. Then we can start. Then we can check ROS topic. Okay, we can check what is the ROS topic command. Then we can check ROS node. Okay, ROS node. Then we can check ROS. Then what? ROS topic we have discussed. ROS message, maybe. Yes, ROS message. Then ROS ls, not now. ROS cd, not now. Okay, I think these four will be good for a start. Okay, so what is ROS run? I already mentioned that it is for running an executable of ROS. Okay, ROS application basically. So we have used ROS run for executing talker and listener. I think you have seen that. So I will show you the exact syntax. Okay, I just stop the talker and listener, and this is how ROS run works. First you can type ROS run. Okay, then there is a concept in ROS called packages, ROS packages. So ROS packages is nothing but a folder. Okay, simply it's a folder with some files, and we have to keep our ROS programs in that package. Okay, basically. So if it is a C++, then it's mandatory to keep everything in the package. But if it is a Python, then we can even put it outside. Okay, Python can run independently, but the best practice is that you can keep the Python script, which is having the ROS API, and the C++ script in a package. Maybe I can show you a sample package, but this topic is actually discussing more in the second chapter. But let me show you a sample package. So let me check just a second. Catkin workspace, yeah. Okay, so there is a concept. I can give you a small idea. Like there is a folder called workspace. Okay, it's simply a folder. We can give any name. It's called the ROS workspace. Okay, so simply in any path, in any location, you can create a folder called Catkin workspace or ROS workspace or Lendin workspace, any name. Then inside that you can just create a folder structure like this. Okay, no need to create this one, only an src folder. Okay, so just creating a folder, inside in that you are just creating an src. Okay, then inside that you have to create the packages, or you have to copy the packages. Okay, so this is the file system organization in ROS. Okay, there is a workspace folder. Inside that you have to create an src, and then inside that you have to keep the package. And there you can create any number of package, and this is how a package looks like. Okay, there will be a package.xml and cmake list, and inside this there will be programs, ROS programs. This is Python script, ROS based, and there is launch file. I will be discussing that. So this is how a package looks like. Okay, so if you want to run a node, okay, if you want to run a node from a package, then what you have to do is you have to use ROS run space the package name space the program. Okay, so here there is talker and listener cpp file, and we have script, python script, that is talker and listener is also there. I mean the talker version of python and c++. Okay, we can write talker or any program in python and c++. So I'm going to run the talker from the hello world package. Okay, so what I have to do is or maybe I can use the already installed package with ROS. It's called ROS CPP underscore tutorial. Okay, so this is a package name. Okay, this is actually available in the ROS installation. In order to check it, you can just click here, other location, then computer, then the ROS is actually installed on opt. There is a folder called opt, then ROS. Okay, now you tick, then you can find the packages installed. Okay, so if you just check for ROS CPP tutorial, here it is. Okay, so this is a ROS CPP tutorial, and we have ROS Py tutorial as well. Here is a ROS Py tutorial. Okay, so what is the use of this package? It's just a tutorial. Okay, in order to test or in order to demo how ROS works, just for education purpose. Okay, so we are just using the nodes inside it. Okay, so called talker. So in order to type these packages which is having lengthier name, just use the tab, just type ROS CPP, then tab to autocomplete underscore t. If you double tap, you will get the packages listing with ROS CPP. Now it's complete, and then you can double tap and you can see the nodes inside it. So talker, you can complete. Okay, so now we just executed the talker executable, and now the talker is actually become a node. Okay, so you may have some confusion, like the executable name is talker, and will the node name will be also talker. That is not actually mandatory. Inside the program you can give any name to the node. Okay, it's not the executable name. So let's see what is the node name using maybe you can use the first command, maybe using ROS node. Okay, ROS node is actually a command, a line tool. So just enter ROS node. Okay, just type ROS node and enter. So you will get the help. Okay, it's very easy to work with. Like ROS node is a command line tool for printing information about ROS node. Very simple, right? So, and there is some commands associated with ROS node. Okay, so if you want to list out active nodes, what you have to do is ROS node space list. Okay, so I got a list of nodes. Okay, one is talker. Okay, that is the node that we have ran, and there is ROS out, which is actually a node starting when we start ROS code. Okay, which is for logging. Okay, we don't need to care about ROS out now, but the talker is there. So if we want to get the information about this node, we can do that. Just use ROS node space info. Okay, there is info, print information about the node, and then after the ROS info, if you have any doubts, you can just type ROS node info and enter. So it will say, if you want to get the information about node, you can type like this, ROS node info, then the node names. If you want to get information about like multiple node or any number of nodes, you can just mention like talker, then ROS out. If you just give, then it will just print the information about these nodes. Okay, I'm just giving talker only for now. Sorry. Now it is printing the information about this node. So what are the information? The information is, first information is the name of the node. Okay, so each node, when we execute a ROS application, inside each program, we can give a name for the node. Okay, so that is what you are seeing here. You can change it. It's not a constant or something. You can change it. Okay, and then the next section is publication. So what will be the publications? Is anybody know what is a publication? Just use the common sense. It's very easy. Like, what will be the publications? Any idea, guys? Any idea? The publications? Yeah.
Like through what Docker is sharing the data to listeners?
Yes, some sort of, but maybe I can clarify. Publications is simply what the node is publishing. Okay, the topics that is publishing. Okay, so we know Docker is publishing what topic? Docker is publishing chatter topic. Okay, so in the publication section, we can able to see the uh, topic name that is publishing by Docker. The name of the topic is chatter, and this is the ROS message of the chatter. Okay, and also I mentioned the ROS out, like all node will publish a log information. So that will be going to the ROS out node. So we don't need to care about the ROS out now. Okay, so first we can ignore the ROS out, but just check the publication. Okay, and is Docker subscribing to any topic? No, right? Docker is not subscribing to any topic. It's simply publishing. And is there any services it's publishing? Basically like logging messages. Okay, so that is common for all nodes. So we don't need to care about this. Okay, so you will also get the PID number, which is actually stands for process identification. I mean, it's for like there will be an ID for each process. Okay, so currently the Docker node is running, right? So the PID value is 4226. Okay, so what is advantage or what is the use of PID? Using this PID, you can even kill this process. Okay, so for example, in order to kill this node, maybe I can use a Linux command called kill. Let me try. I didn't try it before. There is another way to kill nodes using ROS node kill. But if I kill using kill 4226, let me see what happened. Yeah, see, it's terminated. Okay, the node actually terminated. Okay, so that is the use of PID. Okay, if you want to terminate, but we have a command, ROS node command, to kill the node as well with the name. Okay, then you can see the connection. The transport is TCP ROS. You don't need to worry about it now, because the transport, I can just give a brief idea. Like in ROS, basically the communication is happening through a protocol called TCP ROS. Okay, so you will get the information about TCP ROS. Just Google it from the ROS website itself. You will get what is TCP ROS. This is what the underlying communication protocol. Okay, so yeah, so we have seen the information about the Docker. So I just restarted, and then I'm just giving the information of the Docker again. So the PID actually changed. Okay, so we got the information, most of the information, right? So let's see other parameter. Yeah, there is ROS node kill, and this is for killing a running node. Okay, so in order to kill a node, just list this first, and then ROS node kill Docker. Okay, killing Docker, killed. Yes, here you can see shutdown requested. Reason give for shutdown is user request. Okay, is killed. Okay, so like that, you can also, like, another interesting thing is ROS node ping. So which is actually helping us to check whether the node is live or not. So you can see here this command called ROS node is pinging that node. Okay, so we can use this ping to do two things. One is to check the node is alive, and one is to check the latency. Okay, if it is taking too much time for pinging, that means the network is having some latency, and that will affect the communication. Okay, yes, so we have seen the ROS node command, and now we can able to see the ROS topic. Okay, ROS topic. So currently we have seen the talker is publishing a topic called chatter, right? So using ROS topic, if you list out ROS topic space list, then you can able to see 3 topics, and 2 topics you can ignore. These 2 topics, it's basically for the logging. Okay, so currently you can ignore that. Currently, no, like anytime, you don't need too much worry about ROS out. But in some complex robot, if you want to see the logs, then you may need to check the ROS out. Okay, so yeah, so we have the chatter, and if you want to get information about ROS topic, just enter ROS topic command, and then you will get tons of command line command line argument. Like if you use ROS topic list, then it will give the list of active topics, and using this ROS topic tool, you can even publish, you can even subscribe to a topic. So so by publishing it, you are creating a new topic and publishing it. If you subscribe it, you can able to visualize the data flowing through that topic. Okay, so this is the most important command in ROS. Okay, ROS 1. Okay, you primarily like using this command a lot for like visualizing or like just viewing the data flowing through a topic. Okay, so that is the common command, which is ROS topic echo. Okay, so currently the active topics is chatter, so I can use the ROS topic echo chatter in order to subscribe to that chatter topic and visualize it. Okay, so this is what happening. Like when I press the enter, you can able to see the data publishing by the talker is subscribing by the ROS topic command. Okay, ROS topic command line is actually subscribing. In order to view the data, you have to like subscribe. Okay, subscribe. So that is what ROS topic echo does. Okay, so this is the the syntax. Okay, just a sec. Okay, so just a second. And there are some interesting things in the ROS topic, like the echo we have tried, and there is an option to find the bandwidth of the publishing. So using ROS topic heads talker chatter, you can able to see what is the rate of publishing this topic. Okay, so you can find it's almost publishing the data as a 10 heads. Okay, and then there is ROS topic info, which is again useful. ROS topic info chatter. So basically what this node does is that it will display which node is publishing this topic. Okay, so which node is publishing this topic and which node is subscribing to this topic, and what is the ROS message of this topic. It's very useful. For example, if I am just echoing chatter. Okay, so currently it is having a publisher, that is a talker, and it is subscribing to what? They're subscribing by ROS topic command, right? So if you do ROS topic info chatter, you can able to see the publisher is talker, and then the subscriber is a ROS topic. Okay, ROS topic. Okay, so yeah, okay, and maybe I can also publish chatter topic. That is also I can do, because I mean any number of nodes can publish into a topic. Any number of nodes can subscribe into the subscribe from the topic. Okay, so let me publish chatter topic. Okay, using the ROS topic command. Okay, so in ROS topic there is a thing called pub. Okay, and using this command you can able to publish into a topic. So here I'm just publishing chatter, which chatter topic. Okay, and the type of the message is ROS message is string. Okay, and then I will explain what is this standard message and string or something like that. Okay, I will explain. And then the data. Okay, so I can simply do like this, hello. Okay, then I need to put the rate of publishing. Maybe I can use 5 hertz. Okay, now we can try what is happening. Okay, so now you can see the topic is actually publishing hello world, and the hello that I'm publishing from the ROS topic. Okay, and if you do the info of this topic, you can able to see there are 2 publishers. Okay, and there is 1 subscriber. Okay, and again this is one useful command, ROS topic pub, topic name, message type, then the data. Okay, this is a string, so you can just put the string like this. Otherwise you can do like this. After the string, just give a space, then press tab, so you will get an auto text, like the data is what inside this message. Okay, so you can just fill up the thing, and yeah, okay, so this is what happening, and yeah, so if I am publishing some wrong type, for example in ROS there is a inbuilt ROS messages like primitive types like integer, float, string, all these are already available. So these messages are available in a package called standard messages. Okay, which is already installed in ROS. So I can just use int32, which is actually a type of message, integer message, and then I am publishing an integer. Okay, let me publish an integer. Okay, so what is happening? It's actually giving some error, right? It's giving some error. So what is the error? Could not process inbound connection, topic type do not match. Okay, and you can find the error here clearly, std message string versus int32. Okay, so that confirms that you can't publish different messages through a topic. Okay, so that is confirmed. And then you can't subscribe different messages from a topic. For example, if a topic is publishing string, you can't expect integer. If you are expecting integer, it will throw an error. Okay, so this is what we can expect from the ROS topic command. Okay, very useful. And next, so we have discussed ROS run, ROS topic, and also the ROS node also we have discussed. Now I can talk about the ROS messages a bit. Okay, using the ROS message command. So I mentioned that ROS messages are the type of data that is going through the topics, right? That is correct. Okay, that is correct. So I didn't give information about what are the type of data that is available in ROS. Okay, so which all are the type of data and how we are like mentioning what type of data has to flow through this topic. Okay, so just a second, I can just show you that. Okay, let me load this package. Okay, ROS standard messages, sensor messages, then vision messages, then geometry messages. Okay, I think this is enough. Okay, yeah. So ROS is actually having some inbuilt message types. So I mentioned that during the discussion of the basics of ROS, I mentioned that you can send any type of messages through this topic. Okay, and you can send any type of service that you want. Okay, and you can even write custom messages. Okay, for example, through a topic you need to create a custom message which is having an image, which is having a string, which is having an integer, I mean in combined. Okay, combined. So in a single message, okay, you will have an image, string and everything. Okay, you can do like that as well. Okay, so message here, there is two types of messages. One is like I will say standard messages. Okay, standard messages in the sense the messages that are already available in ROS. Okay, that is standard. Okay, so the message types that is already available in ROS, you don't need to like write your own message. Okay, but if you want to define a custom message, you can able to do that. Okay, ROS is having some procedure in order to create a custom message. Okay, so here I just want to share with you some of the standard messages available in ROS. Okay, I'm not mentioning all the message packages, but I think these are some of the commonly using message packages. Okay, so inside these message packages you can see the message definition. Okay, so if you want to, for example, if you want to use a boolean data on your topic, then you don't need to write a boolean message. Okay, you don't need to write a boolean message, and this is what inside a boolean message there is a field called bool. Okay, there is a field called bool, and then there is a the data is a variable name. Okay, so in ROS actually if you want to create a custom message, you can create a file called .msg file. Okay, and then you can just define the field. It can be boolean, it can be an image. Okay, so that I will be discussing on the next chapter, how to create the custom message. But just understand that if you want to like work with these kind of data types, like the primitive data types or like sensor messages, for example, if you want to work with images, there is a image message. Okay, then if you want to carry IMU data, IMU type is the laser scan, point cloud, almost important kind of data message type is available. And if you want to work with like detection, object detection kind of data, you can use the vision messages. Okay, you can carry the region of interest of the detection and all. Okay, then the geometry messages, which is like having messages for carrying the 3D pose, 2D pose array and all. Okay, so so these are the messages that is available in ROS. Okay, you can write programs using these messages or you can create your own. So if you want to see what is inside a ROS message, you can use the ROS message show. Okay, it's very interesting. Like if you want to check what is inside the string, okay, std messages slash string, you can just give ROS msg show, then the message name. Okay, then you can able to see the content of that message. So currently this string message is only having one field, okay, that is a string basically. Okay, so if you want to see one complex message like geometry messages, inside that there is twist, okay, which is actually having the velocity command, and you can see the twist actually having a linear it's actually a vector which is named linear, and there is another vector called angular. Basically this is holding linear and angular velocity, and this vector 3 is having 3 field which is actually float 64. Okay, so this is what I mean. You will get a clear understanding of the message, what is the content of this message, and why we need this command called ROS message. If you know the content, then only you can populate this message with the data. Okay, this is actually like a template. Okay, and you can create a message and then you can add the value to this field and then you can send it. Okay, so this will be clear when you start programming ROS node. Okay, so we have just shown the ROS MSG and yeah, ROS message info. I didn't try it yet. Let me try ROS message info std messages string. Yeah, I mean info I tried. Yeah, okay, list. Let me try ROS message list. Okay, so ROS message list will list down the all type of messages that is currently available. Okay, you can see the list of type of messages that is currently installed on this PC. Okay, so yeah, so I think that is enough for us to start with. Okay, we have discussed most of the command line tools, and now I just want to give an idea about the GUI tools. Okay, after that I think we can conclude for today, and then tomorrow we can start with the turtle sim, and then if we get time we will start with the programming, because I'm giving time for this session because this is a foundation, and if the foundation is not not correct or not clear, then it will be difficult for the programming. Okay, so just 5 minutes to introduce some of the popular graphical tools in ROS. Okay, so I'm still running the talker and now I'm running the listener as well. So there are two popular tools, two popular GUI tools in ROS. One is called RQT. Okay, RQT. So just type RQT and press enter. So you will be like getting mostly getting a window like this, a plain window. Okay, so this is not a simple tool that you imagine. This is a very useful and very complex as well. So the thing is that from the menu you can able to see a field called plugins. Okay, just click the plugins and you can able to see the plugins available in RQT. So for example, if you want to visualize the node graph, which is a computational graph, you can able to load this plugin called node graph. Okay, you have to used to with these plugins. Okay, sometime it will give confusion, but if you are like commonly using this plugin, then you can easily take it. So I'm just clicking it and you can able to see the node graph. Okay, and if I want to subscribe or just monitor a topic graphically, I can load a plugin called topic monitor. Okay, so that will be loading along with the node graph. Okay, so currently I can able to visualize the topics. Okay, And in order to monitor or subscribe to this topic, I just want to click here, and then you can able to see the bandwidth. Okay, just a second. Let me check it is running. Okay, it's running. Let me try. Yeah, actually it should monitor the data here. I'm not sure why it is not. Let me, maybe a bug in the program, but the expected result is this. I can just monitor this. If you click it, it will start. Oh, okay, there is an error, I think. Okay, okay, I think there is some issue with the topics or something. Yeah, that's why it is showing error. Let me see. Yeah, now it is working. Okay, now it is working. Let me start the listener as well. Yeah, it seems working. See, you can see like it is publishing at 10 heads and the bandwidth, because these two processes are communicating with each other over the sockets. So there is a data transfer happening, right? So this is a text data, string data. So it's a bandwidth is like 190 bytes per second. Okay, so if you send images or point cloud which is having MB size like 5 MB per second or 10 MB per second, so you have to be careful while sending the images and point cloud as a topic. There is an option called nodelet or shared pointer. So that will be discussed in the upcoming chapters. That is actually very safe for handling high bandwidth data. Okay, so here you can able to visualize the topic name and the data. Okay, and also like that you can close that plugin, and there is a service caller. So these things actually very useful while working with ROS. Okay, there is a runtime monitor, so it will be displaying the log information. There is process monitor, which is actually showing the the number of nodes running and its CPU utilization, which is again very useful. And then package graph, I didn't work with it. Just a sec. The node graph we have tried. Then the logging, if you want to check the logging information, basically you can able to see the log messages. So in ROS we can print the information as a log. Okay, so that information can be read from these tools. Okay, you can find the log information printing by talker and listener, and this is just an information. Okay, you can actually set the severity of these printing, like it can be an information, it can be a warning, it can be an error, it can be a fatal, or it can be a debug. Okay, so you can set the severity of the message. For example, your node actually crashed somehow, and then you can just print a ROS error message. Okay, so that will be listing here, so you can understand there is an error happened. Okay, and also like warning, fatal, all these things can be used. Okay, so this will be, you will be understand while programming it. Yeah, so that is one tool called RVs. You can try it. And then the next tool, the last topic, the RVs. Okay, RVs has no role here, but I just want to show you. Just simply type RVs on the command line, and you can able to find a 3D viewport. Okay, so this is mainly for visualizing the sensor data. Okay, sensor data. So this kind of information like camera, map, laser scan, point cloud, all this information can be displayed, not like simple topics and all. Maybe I can just show you a demo of RVs. Simply I can start the USB. Yeah, let me try with the USB. Okay. Yeah, I'm just connecting my USB is already there. Let me try to check my USB cam. Let me connect into it. Is it connected? Okay, yeah, it's connected. Connect. Okay, I'm just connecting my USB cam into the VMware, and then I'm just checking the camera using an application called Cheese, and you can visualize it. Okay, so now I'm starting a ROS node to read the sensor data, the camera data from the cam, and then publishing as a ROS topic. Okay, so no need to worry about the command. So currently I'm reading from the cam, and then it is publishing as a ROS topic. That topic can be visualized in RVs. Okay, image view, and there is an error, so just want to set the frame, and you can able to see it is actually like, just a second. Oh, it's actually closed. There is a bug actually. Let me try from here. Image will be fine, and then yeah, so you can able to see my image in RVs. Okay, so RVs, there is actually okay, this error. Yeah, I can fix that. So basically I think you got an idea, right? It's for like visualizing these data, like laser scan, images, point cloud, all this stuff. Okay, so these are the commonly using command line tools and GUI tools. Okay, so very important. Just practice it, and tomorrow we will be working with the ROS Turtle Sim in order to understand the possibilities of Turtle Sim, what are the things that we can learn. And after that I will be like discussing about workspace and package, then the client libraries. Okay, so I think that will be the this much topics. Okay, yeah, so now it's a time for Q&A. If you have any question related to the command line tools or GUI tools or the Hello World program, let me know. Yeah, any question, guys? Any question? Do you need any clarification or something? Yeah, Karthik, yeah, tell me. Yeah,
Hello,
I
sir.
can. Yeah, I can hear you.
Sir, it's actually about gazebo
Okay,
simulator.
okay. So yeah,
Yeah.
actually the gazebo. Yeah, you can ask anyway.
Yeah, sir. While using the building editor in gazebo, it's crashing every time
In the
whenever it's
VMware.
opening in my system. Yeah, and I have double boot my system.
Okay, you dual booted your system. Okay, then
Yes.
okay, so yeah, there are many reasons for that. For example, in VMware there is a flag to set, but if if the gazebo crash, let me. You can send the screenshot. Okay, just the terminal screenshot. So I will check it. There are many reasons for that. Okay, so you
Okay.
can you can just execute gazebo and then you can send me the screenshot, like what is the message that you are
Okay.
getting. Okay.
Okay.
Okay. Yes.
Okay.
Yeah. So like these simulator called gazebo that we are going to see, which is actually using like the GPU, and if the drivers are not proper, or if the any issues with the operating system, mainly regarding the driver of the graphics card, it will crash. Okay, so sometime we need to change the hardware acceleration into software acceleration. So or we have to downgrade the OpenGL version to the current OpenGL version is like OpenGL 3.x. I think that is what Noetic uses, but we have to downgrade into 2.2. But it will depend. Like I can't identify the exact reason. I can only find it after getting the screenshot, error screenshot. Yeah. Any more question, guys? Any more questions?
Sir, have you tried to install ROS in Arch Linux instead of
No,
Ubuntu?
not yet. But just check. I think the compatibility is there in Arch Linux, but I'm not sure it is. We will get the packages, or yeah, I think it is there, but not fully built. They are showing the compatibility. Uh,
Yeah, I did try it. Like few packages are installing and few Gazebo packages they are failing to
yeah,
install. I couldn't find
yeah,
any other.
they are giving the desktop full. That means the gazebo will be there, but there will be bugs, I think,
And,
because the thing is the full compatibility is for Ubuntu. I'm not sure how well they maintain the Arch Linux binaries. Um, and so gazebo is not working, Ram?
yeah, like it's not even installing. Actually, the command which is given there, that ROS
Yeah.
desktop full, that command doesn't work. So I have to individually install each packages separately, like Gazebo separately, like
I
visualization
think
separately,
that will
likewise.
create issue, I think. And also, I'm doubting that this is a latest instruction to install ROS Noitic, because better will be like searching in Google to get some other blogs or something. I'm not sure it is the latest instructions. Maybe we have to add
Yeah.
some in Ubuntu. If you observe, you have to add the source list and keys and all, right? So in case of Arch Linux, I'm not sure like it directly able to install the desktop full. Do we need to add any other thing? Are there?
Like I didn't find it in. I just looked at this page and then I tried to install each package separately. Like in the fourth individual packages it is mentioned,
Okay.
right? So I
Yeah,
tried using
mostly
that.
if we try to install individually, I think that will fail mostly. We need to
Yeah.
find a correct way of installing. Mostly the things available on wiki may not be latest. That is again one problem.
Okay.
So better will be like one option maybe you can check is like building from source. It will take some time, but
Yeah.
source installation mostly work. That is shown here.
Okay.
Yeah, maybe you can try that. Just yeah.
Sure. Let me
Yeah, and
try that.
Trishant is also mentioned like for our supporting library has to be built manually. Okay, Trishant. I think, yeah. So maybe the source build may help. It is taking some time, but if you have internet and good PC, I think it will work. Yeah, and also regarding the source installation, I assume this instruction will be latest. And let me see, this source installation is also for Arch. They're saying Ubuntu, Debian, Fedora, generic. Maybe we need to go with the generic. Yeah, because Ubuntu, Debian, Fedora is using another thing. So build. Yeah, I think generic, we can go with the generic and try to install. Yeah. Okay. And also, if you are aware of Docker, that is a best option to try ROS. So Docker will be the best option, because Docker is not like the VMware or like the VirtualBox. It will not give additional headache for the operating system. It will work along with the the Linux kernel. So you can also think about Docker images. You will get Docker ROS Noitic desktop full images, or you can build it. Okay, so this is again one good method. If you are planning to deploy your ROS application in future, Docker knowledge will be very helpful. Okay, so this is also one thing you can consider without loading your operating system. Okay, any more question, guys? Any more questions? Okay. I think we can then conclude. So tomorrow we can start discussing on the Turtle Sim workspace. Maybe I can just copy the topics so you will get an idea. Just a second. Yeah, so these topics we will discuss tomorrow. So try to attend these sessions because very important, the fundamentals. Even if you learn the fundamentals from some other course, I think attending these lectures will still be helpful. Okay, I may be discussing some other concept that you don't know it. So yeah. So see you tomorrow, guys. So I will be uploading the video today itself, so you can also watch. Okay then, good night and see you tomorrow. Bye everyone. Bye.
Bye.